Here are five computer science concepts I picked up while learning Rust. For some background, I transitioned into software engineering by going through a coding bootcamp. So I learned stuff like JavaScript with Node.js, React, stuff that could get me ready for entering the workforce as soon as possible. So my knowledge of computer science was sorely lacking, but for whatever reason, I chose to learn Rust as my second programming language. For the final project of the bootcamp, it was tough, it was fun, and I learned a lot from it. So these are the computer science concepts that I picked up while learning Rust. The first concept that I learned is that memory must be managed. When I was learning JavaScript, there's nothing that we have to think about it. We'll just do like, we'll do let x equals to one, let foo equals to bar, and that was the end of it, right? Like we did not need to think about how variables were or values were created, how um the values are actually stored in in the computer's memory. We did not need to think about what how much memory, right, each value takes up, stuff like that. Because all these things, when you write JavaScript, you just write JavaScript. There is no need to think about it. So what I've learned is that actually there is this thing called I think there are a few related concepts, but I think the big one here is that there is a garbage collector, right? In JavaScript, JavaScript is an interpreted uh, language. So at runtime, there is a garbage collector that runs in the background that takes care of memory management for you. That means when you assign the value, let's say we talk about this is supposed to be X, this is supposed to be full. If you say let's say let best, let's use an object this time, equals to some object, right? Um, the what the garbage collector does is that it tracks references. I'm probably skimming across a lot of details because this is all still very new to me, but the garbage collector tracks references and users of these values, these objects in memory. And when the garbage collector at certain points in time deems that um, the values are no longer being used via some algorithm, the garbage collector then marks these values as unused and essentially um, wipes them clear from memory or designates those parts of memory as something that can be used again, right? Whereas in Rust, it's not so straightforward. I think all the things that I said above are things that I realized uh, that me as the software engineer, as the programmer, right, have to think about or at least be aware about when I um, use Rust. So in Rust, um, there are concepts that I will get to later, but I think one big one is the idea of like a stack and a heap. What's the differences there, which I think is one of the points I will talk about that I learned as well. Um, and also how memory is free, right? Because with a garbage collector, the garbage collector is in charge of freeing the memory that is no longer used. But in Rust, um, that management is more down to me as the developer. Of course, Rust has certain um, rules, certain features. I think the borrow checker is one that helps with making memory management easier because I think there are a lot of pitfalls that programmers of the past experience with languages that hand over control, a lot more control, um, without some of these guardrails. So these are some of the concepts that I learned about memory management with Rust. Number two is this idea of, like I mentioned earlier, of the stack versus the heap, right? Uh, what I've come to understand is that these are two different ways of managing memory, managing a program's memory. Um, for a stack, as the name suggests, it is, well, a stack, right? Uh, so, and what I've come to realize is that usually the stack is associated with a function call. So let's say we have some function, let's just call it main. Then you will have let x equals to 1, let y equals to 2, um, and function. What the computer does, again, as the name suggests, is it allocates memory accordingly. X here 1, y 2. I think I'm probably missing a lot of details here. I'm glossing over a lot of details because there's differences as well, I think, between uh, the variable and the value that the variable stores. But the basic idea here is that this is a stack. Then when we talk about the heap, this is a different color perhaps. The heap maybe is something like, as compared to the stack, a stack is a stack of stuff. The heap is a heap of stuff. So a stack goes up incrementally, and when the function returns, yes, I forgot to mention, when the function returns, items are popped off the stack sequentially. So you pop off y2, you release that memory, then you release x as well when the function returns. Then for um, the heap is a little bit more flexible, I guess. Uh, I think as the name suggests, the heap, the rather the stack requires fixed sizes, right? It can only store things that um, the program knows the exact size of, which brings me back to point one, right, about memory management, where different values have different sizes and take up different amounts of space in memory. So if we think about something like uh, a string um, that we want to grow the length of, let's say if we talk in JavaScript, right? You do let x equals to hello. And if we want to then grow the length of x, right? Let's say let's actually use a vector example. Because I don't recall the string methods, but um let x equals to 1, comma 2, right? This is JS. Then we do x dot push 3, right? We are changing the length of the array, which in Rust is called a vector, because an array is a fixed length of values whose size is known at compile time. So Rust arrays we can store on the stack, but Rust vectors or JavaScript arrays, we need to store on the heap. Why? Because let's say, let's go back to our stack here. If we do the initial one, right? You have a vector. Oh, sorry, you have a JavaScript array. You do 1, 2. Then, so this is 1, 2. Then you do x dot push. 3 here. Here, we allocate memory on the stack for y, it's 3. But then we want to extend the length of x here, right? Or rather, we extend the length of x by pushing in another value. However, the slot is taken up here, not there, here by y already. So we can't push a value there, and that's where the heap comes in, because the heap is just, I guess I understand it as is it unordered memory? You can just add stuff here. So let's say this is x is 1, and this is the end of one memory chunk is 2. Um, and then let's say y was stored here, right? Just for the sake of example, if we want to add another value to the x array, what what the computer does, what the program does, is it actually takes the array here and moves it somewhere else, right, where there is enough space. So let's say here, right, here 1, f2, and then it's able to push in the value 3. So this is what I learned, because as far as I understand, I think in JavaScript everything is stored on the heap. Because it's garbage collector as well. I'm not sure if those concepts are linked. But when learning Rust, I was forced to um, learn and understand some of these concepts better, because the memory model of it is just so different from JavaScript. Number 3, pointers are a thing. So in JavaScript, when we pass values around, let's say we do let foo equals to, if we talk about primitive value like a number, right? Like 3, and maybe let bar instead be an object where you have some fields, right? The difference in passing these two values around is that, let's say when you let foo2 equals to foo, and you let bar2 equals to bar, the difference is that for foo, when we assign foo to foo2, the value 3 is actually copied over to foo2. That means a new, um, so-called a new instance of the value is created and assigned to foo2. Whereas for bar, when we assign it like this, it's as good as saying that we are passing the object here, right? The object here. Oh, this object, this entire object, by reference over to bar2. So if we then mutate bar2, uh, let's say bar2 dot des equals to uh, John Doe. Sure. When we do bar dot des, we also get back John Doe, because the value here is passed by reference. And this is, I think, the only thing about pointers, right, that I can think about when it comes to JavaScript. But in Rust, what I've learned is that pointers are explicit. That means we can pass pointers to anything, right? Like if we use the same let foo, this one is in Rust here, right? We can say let x equals to a pointer to foo. right? Um, and this is a way of thinking about memory that I think I mentioned in uh, point one, where memory must be managed, where in Rust, a lot of the underlying computer concepts or underlying things about how the computer actually works is made more explicit to me as a programmer as compared to JavaScript, because pointers are in essence just values. They are values indicating a specific memory address. So they are also values that can be manipulated and managed by the programmer if they so choose. Um, so while JavaScript does not have this idea of manipulating pointers in Rust, this idea is there. The What I've come to realize is that while uh, the way we work with pointers in Rust um, follows certain strict rules, if we use other languages like C, these rules are not there, and we can do a lot of, I guess, there is a lot of flexibility available to us as a programmer, which has its pros and cons, but that is something for learning another time for me. So pointers are a thing. There are pointers in computer programs that are used, and that is something to be aware of that I learned from Rust. Number four, um, there is more to arrays and objects than meets the eye, at least when using them in JavaScript. So when we talk about arrays and objects in JavaScript, um, an array is just you know an array of values, the list of values, things that are next to each other in memory. I'm actually not sure of the exact implementation. Well, don't know if it's a linked list, but anyway, an array is just essentially a list of values that uh, we can, you know, push values into. You can pop values from. There's slice, there's shift, unshift. There are so many methods on the array type in JavaScript that allows us to mutate um, uh, an array. We don't think about size. We don't think about types. You can have a string, right? Hello, followed by a number, right? And even a boolean in JavaScript, and that is all fine. Um, in Rust, there is actually a difference between an array and a vector, and that is something that uh, was quite eye-opening to me, because um, learning about these two different data structures actually shed a lot of light into how they work under the hood. So in Rust, an array is something which we go back to point, don't recall, one or two, which is stored on the stack, right? It is it's a different color for Rust. Um, an array is stored on the stack, right? So if we think about the stack, like oh, if we think about the stack, like we mentioned just now, um, when we want to store something on the stack, we need to know the size of the values, right? Because um, if we talk about like the function call, um, if we talk about the function call, you can have an array that's allocated here. You mutate the array. You create some new variables. Sometime after that, right? We need to know the size of the array, because we need to use a specific amount of space on the stack so that the next value that is allocated, the next variable that you create, knows where to go on the stack. And even if, let's say, you use these two space here, these two memory slots, so to speak, on the stack, then you allocate a variable here. If we want to then mutate the array, right? How are we going to add an element? We can't. And because we will be overriding the variable here, right? Um, and if we want to, similarly, if we want to remove an element, then we are leaving a blank space there. So an array in Rust needs to be a fixed length. The size needs to be known at the time we define the array. I think the syntax is like this. So this will be an array of eight unsigned 8-byte integers that is allocated on the stack. So the program, the compiler in this case, knows exactly how much memory it needs to leave for the array. For JavaScript arrays, the in Rust, the data type that is much closer to that is actually a vector. Um, so a vector, what I've come to learn is that it's essentially what they call a smart pointer, right? It's a pointer that points to a memory location on the heap. So if we think about what a JavaScript array can do, you can add elements, you can remove elements, you can shift elements around. In Rust, you can't store elements of different types in the same vector, but even being able to change the size of the vector requires us to store the vector data somewhere else, and that is on the heap, because the heap is somewhere uh, where the use of memory is flexible. If we grow the vector and the required memory bounds do not allow the vector to grow beyond that size, the computer is able to shift the data from that location, which does not have enough memory, to another location in the heap. And all it has to do is update the pointer here, to point at the new location on the heap. Um, and this is actually how uh, vectors are, um, or rather, this is the difference with how arrays and vectors are in Rust, where vectors are a little bit more like the arrays that I learned in JavaScript. And if we go back to requiring a fixed size, that's why we use a pointer, right? Because a pointer is something whose size does not change. It is a fixed value, or I think more specifically, a fixed data structure which stores some information about the vector, such as the location, like I think things like the size and other details that I'm not too aware of at this moment. So there is arrays and vectors uh, uh, in Rust, and how they are more to arrays, uh, more to just JavaScript arrays that meets the eye. As for objects, in JavaScript, when we talk about objects, let's say foo equals to a new object. In JavaScript, I didn't really need to think about like how an object works. It's just, I can do foo dot a equals to 1. Then I can do foo dot b equals to 2. And if I log console.log foo dot a, I will get 1, right? And if we do something like, and a field that doesn't exist, uh, depending on behavior, it might be undefined or it might crash. Yeah, I don't recall the exact behavior here, but um, this is all I had to think about when I was using objects in JavaScript, right? Um, it's just a collection of keys and values. But I think when I started to learn Rust, that there wasn't this idea of object really, right? Um, in JavaScript, you could even do like numbers as the keys and whatnot. But I think in Rust, the closest approximation, which again is what I really appreciate about Rust, right? Because it helps me learn computer science concepts, hence the video, as well as it exposes me to a lot of the underlying concepts, which is um, we need to use a hash map. And just coming across this idea of a hash map forced me to look into what is it, right? How does it work? And the idea of the hash map at a broad level is that you provide it a key, which sounds then it will return a value. Which I mean does sound very much like a JavaScript object, but I think the key here is that understanding how the hash map works is part of using the Rust implementation because when we talk about Rust, we need to think about okay, what are the uh, what is the hashing algorithm that is being used? What's the likelihood of a key collision, right? Where uh, what I mean by a collision is that the way a hash map works is that um, it needs to convert uh, the key, which is maybe a string value, right? Let's just say it's a string value full into a memory address. And this memory address is where the value is being stored. So if we have another key bar, that is another memory address. And what I mean by key collision is that there is an algorithm that is needed, right, to convert full into bar, or rather full into the address as well as bar into the address. And this is the hashing algorithm. Um, we can imagine a world whereby the hashing algorithm uh, just returns one every time, right? It returns the same value every time, one. No matter what key you give it, it will always return the same address. So if we give the hash map two keys, two different keys, it always returns the same memory address with which we should store the data at. And that does not work because, or rather, um, there are ways to mitigate key collisions that I've read and come across that at this moment I still don't fully understand. But the point is, hash maps have so much more um, 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 going on, right? Uh, to just being a collection of key value pairs. I think that is a lot that I rambled about to just say that the beauty of Rust is that um, it exposed me to some of the concepts of how uh, an object-like type in JavaScript actually works under the hood. And that has shown me and pushed me to learn some a little bit more of the computer science concepts in that sense. Number five, be careful with mutability. When I was learning JavaScript at the start, in the coding bootcamp, there was already the let and const keywords, so that already helped uh, put some emphasis into like why it was important to have a difference between the two. So uh, the general idea was that if you want a variable, uh, let mutable, right? Let mutable equals to one. Um, you could just let me change this to a shorter variable name. Let m equals to one for mutable, right? Um, with JavaScript, since I declared this variable with a let, I can easily reassign it to anything I want. Um, even like a string. But if I use const uh, I for immutable, um, right, I can no longer reassign I to something else, right? Like three or something like that. That is no longer possible. However, in JavaScript, while we can't reassign values that have been declared, reassign values to variables that have been declared with the const keyword, um, we can still modify these values. So let's say um, const array equals to an empty array. This array object is actually still mutable, right? Because we can do array dot push some value, and this will work. JavaScript won't complain. But I think, but with Rust, I think the one very important concept that I learned, and that I learned while learning the language is that mutability is something that we need to be very, very careful of. And I recognize that this perhaps isn't really a computer science concept per se, and more of uh, a good software engineering practice. Um, but I think it's still something very important that I learned while I picked up Rust, which also helped me understand a little bit better about some of the underlying things that are going on in the computer. So um, in Rust, when we want to, when we declare a variable, it's also with the let keyword, let x equals to one, right? But this value is actually, this variable is no longer mutable. What we want to do, or what we have to do, is we need to declare let mut y equals to 1. We can then um, mutate this variable y by reassigning it something else, or changing its value even. Um, I think this is a little bit better explained with something like maybe a vector. If we say let foo equals to a new uh, let's use other syntax. I don't recall the macro syntax. Like new, right? If we want to push a value into foo, this is actually not possible. The compiler, the Rust compiler will complain because what we are missing is actually the mutable keyword over here. So we need to do let mute full equals to vet new. Then we can mutate um, the variable full. And what I've learned in exploring this topic is that um, I think the idea of mutability and why it's so carefully um, managed in a language like Rust, and also I've come across other languages, especially functional languages like Elixir, which has immutable values by default, is that mutability is something that can be very hard to keep track of, and it can be the source of many subtle bugs. Um, so Rust um, handles this by forcing us to use the mute keyword when a variable needs to be mutable. Uh, I think the reasons are still something that I am trying to understand. I don't claim to understand it well at this moment, but I think I came across this other explanation whereby um, John Jensen, he goes by the handle online John who? Great Rust YouTuber. I love his content. He shared this idea of the mute keyword instead being an exclusive reference rather than the mute keyword signifying that this variable is mutable. It signifies that this variable holds exclusivity over the value, and then that's why it is safe to mutate that value. Um, Again, plenty of things that I don't understand yet that has to do with various other values referencing that value. That's why if it is an exclusive reference, it's safe to mutate. But if it's not an exclusive reference, mutating the value could result in subtle bugs, stuff like that, that I'm still wrapping my head around. But that's essentially the gist of what I understand right now. And if we go back to JavaScript, I'll use green this time. If we go back to JavaScript, I think this is a source of bugs that I've come across before as well in my career, in my short career so far. So let's say we have this const array, right, that we declared above, and we have a function, uh, function ma. Let's just call it that for mutate array, uh, whereby it takes one value, it takes an array, right? It does array dot push one value, and and that's it. And what we do, we can imagine perhaps this function ma is a library function. So we don't see the internals of it very clearly, right? And we pass it our array. We don't expect the library to mutate our array. We expect it to achieve some form of functionality for us, right? And then further below, we might do things like, call array, oh, array dot length, right? We might be expecting a certain value because we think that we are managing the entire array on our own, or we might call certain other methods on the array, expecting there to be a certain number of values only. But because the array was mutated without our knowledge by some function that we could have called, um, which can be very hard to find and understand as well, this leads to a lot of subtle bugs. Um, and there are linters out there that I've used as well that have pointed out this to me as well to help me avoid these bugs, thankfully. But this is how I've started to grasp and understand why mutability is something to be careful of. We don't need to avoid it completely, of course, because it is necessary to have mutable values occasionally, but uh, that's where I think Rust with this clear, explicit mute word has made it clear to me that, hey, mutable value, you might want to think deeply about how this is needed, why is it required, how will you be using this, so on and so forth. So be careful with mutability. If you made it to the end of the video, thanks so much for watching. I'm trying something new where I share about things that I learned in my journey through computer science and software in general. Um, as mentioned, I made a career switch a couple of years back, and since then, I've found myself to be rather obsessed with software and learning how things work. As that's what I find I really love to do. So, as I learn how things work, I wish to share them with the world. Um, Number one, so that I enhance my own understanding, because I believe teaching someone else, or at least attempting to teach, is one of the best ways to enhance my own understanding. And number two, by doing so, in hopes help some of you out there um, who are also learning something new, who are also pushing ahead to grow, to develop yourselves, right? In this rather crazy world at this moment, um, and to show that um, never stop learning. I think learning is wonderful. Learning is amazing. Building and understanding of things feels great, right? And that's what I want to try and do with this channel and subsequent videos as well. So if that's the kind of content that you would like, do subscribe to the channel. I plan on producing more videos similar to this, I think, where I share about concepts that I've learned while learning computer science, as well as in my journey of software engineering, and explaining it to you guys. So, yep, subscribe, and I'll see you in a future video.